Somebody asked about how to do number 41 on the homework. This is from section 9.3. Number 41 is saying, if this is my infinite series for a function, we're looking for what is the 12th derivative of that function at x equals 0. In order to do this problem, we have to remember that the way to find a general term for a Taylor series is you take the nth derivative at 0 divided by n factorial times x to the n. So for us, n is going to be 12 because we want to figure out what the 12th derivative is. So we're going to use n equal 12. And so if we used the Taylor series method, we would get that the 12th derivative at 0 divided by 12 factorial times x to the 12th would be the 12th degree term. But if we use this definition, the 12th degree term would be x to the 12th. If we use this definition, n is equal to 11, over 11 factorial. So if I want to solve for the 12th derivative, I'm going to start, and this is what I'm solving for because I'd like to know what that is. I'm going to start by dividing by x to the 12th. So I get this 12th derivative, which is what I want, divided by 0, at 0, divided by 12 factorial is equal to 1 over 11 factorial. So if I want to solve for this derivative, I'm going to multiply both sides of this equation by 12 factorial. So the 12th derivative would be 12 times 11 times 10, etc., all the way down to 1, divided by 11 times 10, etc., all the way down to 1. So all of this is going to cancel, so the 12th derivative would be 12. So we can use Taylor series, if we have them, to figure out derivatives for our original function, because we can go back to the way we find a term in a Taylor series is by taking the derivative divided by the factorial times x to the n.